Hi data scientists, my name is Jessica and today we're going to be looking at this problem here. So we want to draw a card from a standard 52 card deck. So that's 52 total cards with 4 suits each, with 13 possible cards for every value from ace all the way to king. So just a normal card deck. And we're going to draw a card 100 times while we're placing the card that we're drawing. And we only count a success if we draw a card labeled queen. So we're going to draw 100 cards and we're going to separate them into successes and failures. If we draw a queen, that's a success. Any other card is a failure. So we want to use Python to determine what percentage of results have less than or equal to 11 cards labeled queen and save this as a variable called cards. So we're going to be using a binomial distribution to solve this problem. And so really quickly, let's just go through what a binomial distribution is and why we're using it. So a binomial distribution is a probability distribution, since we want to find a probability at the end. And we're using it because, well, our little simulation here is looking at yes or no questions, right? Did we draw a queen or did we not draw a queen? There are only two options. Obviously, when you draw a card from a deck, there are multiple options, but we've condensed it into if we drew a queen, that's a yes, and if we didn't draw a queen, that's a no. So when we have two options, we're going to be creating a binomial distribution. So there are two steps to this problem. First, we want to create our distribution. And then secondly, once we have our distribution, we can use that distribution to figure out what is the probability of, out of these 100 times that we're pulling out cards, what's the probability of getting less than or equal to 11 cards labeled queen. So then we want to find our probability. So let's take a look at how we're going to do that. First thing, we need the Binomial library from Python. So that should be given to you at the top of your code. We're going to, from scipy.stats, we want to import Binomial. And next, we're going to create our distribution. So we can just store that in a variable called dist. We're going to be using the binomial function, which is called binom, which takes in two variables. So it takes in an n, which is just how many times are we going to be doing this simulation. And we're going to be doing this 100 times. We're going to be repeating it 100 times. And then we want to put in the probability of a single success. So in our problem, a success is if we draw a card labeled queen. So what is the probability of drawing a queen in a standard deck? Well, you have 4 queens, 1 for each suit, and 52 total cards. So our probability would be 4 over 52. So now that we have our distribution, then we need to find our probability. So how are we going to do that? Well, it's useful to take a look at what our distribution actually would look like. It could look like anything, but let's just assume it looks something like this. So our y-axis is a probability. So it goes from 0 to 1 because it's a probability. And our x is some value like k, which is the number of queens. So out of these 100 times, what is the, like, if our k equals like 4, then this value here would be the probability of getting 4 queens out of the 100 times that we're doing it. So if we're running our simulation like 100 times, then the probability of getting like 75 queens is quite low, right? Like you're not going to get 75 queens every single time because there's only 4 queens in the entire deck. So we can expect this probability value to be quite low. But what we want is the probability of getting 11 or less queens. So we have some value 11. And not only do we want to find this, but we actually want to find the probability for all the values less than 11. So easy way to do that is just take the area under this curve. And that's exactly what your CDF function does. So all you have to do is in your variable called, they want to save it as cards, we're going to do our distribution.cdf. And then we're going to pass in a value of 11. And what this is going to do is it's going to find the area under the curve for every value less than or equal to 11. So there's a similar question to this one where they want you to find the probability of like getting something greater than a certain number of cards. And for that, you would just do 1 minus this value, because this is going to give you less than or equal to 11. And since our probability will always add up to 1, to get greater than, all we have to do is do 1 minus. So yeah, once we have our cards variable, this should be storing the probability now, so we can just go ahead and return cards. So your final code should look something like this. And yeah, hopefully that was helpful.